Okay, day 16 solutions. Got a request for almost all of them, 1, 3, 4, 5, 6, and 8. Solving trigonometric equations. Not the easiest thing in the world, but it all goes back to the inverse trig function, which is using the unit circle. So we're just going to solve this for x. I'm going to go ahead and add 3 and divide by 4. So the cosine squared of x is equal to 3 over 4. Solving for the cosine of x, so I need to take the square root of both sides. Remember, when you do the square root, you have to take the plus and minus. So that gives me the cosine of x is equal to the plus or minus the square root of 3 over 2. All right, well, that means that the cosine of x is equal to root 3 over 2. Just break it into two separate problems, and the cosine of x is equal to negative root 3 over 2. Taking the inverse cosine of both sides, that means that x is equal to the inverse cosine of root 3 over 2. And x is equal to, let's just go ahead and write it differently, the arc cosine of negative root 3 over 2. All right, now we're down to the unit circle. So what angle has a cosine of root 3 over 2? And that's going to be pi over 6, or 30 degrees. Now, the cosine is positive in the first quadrant and also in the fourth quadrant. So I got a reference angle of pi over 6 here. So that means x is equal to pi over 6 and 11 pi over 6, because we are solving this on the interval from 0 to 2 pi. All right, so now the inverse cosine, negative root 3 over 2, well, it's the same exact thing, except now we're going to be in the second quadrant and the third quadrant. So we've got reference angles of pi over 6. So, of course, 180, or pi, is 6 pi over 6. So one short of that is going to be 3 pi over 6. And one more would be 7 pi over 6. All right, number 3 is 3 cotangent squared x minus 1 is equal to 0. Well, I never did any with the cotangent for you, or the secant, or cosecant for that matter, but we're going to treat it the same exact way. I'm going to go ahead and add 1, divide by 3. So that gives me the cotangent squared of x is equal to a positive 1/3. Well, if you don't like working with the cotangent, just change it to the tangent squared of x. Well, how can I do that? Well, the cotangent and the tangent are reciprocal functions, so I'm not dealing with 1/3 anymore. I'm dealing with 3. So I'm going to take the square root of both sides again, and when I take the square root of both sides, I have to do the plus or minus. So that gives me the tangent of x is equal to root 3, or the tangent of x is equal to negative root 3. So x is equal to the inverse tan of root 3, and x is equal to the inverse tan of negative root 3. All right, now we're back to the unit circle. What angle has a tangent of the square root of 3 and is positive? Well, the tangent's positive in the first quadrant, and that's going to give me the reference angle of pi over 3. The same thing down here, reference angle of pi over 3. So x is equal to pi over 3, because again we're going from 0 to 2 pi. And this would be 3 pi over 3 plus 1 more, or 4 pi over 3. Same exact thing here, except we're looking for where the tangent is negative. Well, the tangent is negative over here in the second quadrant and over here in the fourth quadrant, with a reference angle of pi over 3 again. It all goes back to the unit circle, knowing the ordered pairs around there. So this gives me two other solutions. This is one shy of 3 pi over 3, or 2 pi over 3. And this is 1 pi over 3 short of 6 pi over 3, so that's going to be 5 pi over 3. Okay, number 4, cosine cubed of x equals cosine of x. Looks really confusing. Remember, you just treat these like algebraic equations. Don't get confused with the cosine or the sine or whatever it is. It's a polynomial. Think about it. So I'm going to get the cosine cubed of x minus cosine of x, set it equal to 0. I'm going to factor it, so I'm going to factor out the common factor, the cosine of x. And that leaves the cosine squared minus 1 is equal to 0. This actually, you could factor as a difference of squares, or we're just going to do the square root property. So I'm now going to take each factor. Cosine of x is equal to 0. Cosine squared of x, forgot that here, is equal, minus 1 is equal to 0. So cosine squared of x is equal to 1. Taking the inverse cosine, so x is equal to the inverse cosine of 0. And over here, taking the square root of both sides, and then taking the inverse cosine, let's just go ahead and make it 2 steps. Cosine of x is equal to plus or minus square root of 1 is just 1. So that's going to be that x is equal to the inverse cosine of 1, and x is equal to the inverse cosine of negative 1. All right, so back to the left side. What has a cosine of 0? Well, where's my x value? 0. My x value is 0 at pi over 2. So here I get 0, 1. So my cosine is 0. So x is equal to pi over 2. And also down here at 3 pi over 2. All right, now where is the cosine equal to negative 1? Well, it's going to either be here or here. Well, no, it's not. It's here. So that gives me the ordered pair of negative 1, 0. So that is x is equal to pi. And of course, where is it equal to positive 1 is going to be right over here. So x is equal to 0. I choose 0 and not 2 pi because, again, the interval that we were told to solve this on was 0 to 2 pi, including 0, but not 2 pi. So that's why this answer is 0. All right, number 5, we got sine x minus 2 sine x cosine x equals 0. Well, we have two terms with a common factor of sine x. Let's just factor that out. So there's sine x. So it's going to be 1 minus 2 cosine x, and that equals 0. So let's take each factor now and set it equal to 0. So sine x equals 0, I can just say that x is equal to the inverse sine of 0. I'm going to go ahead and subtract 1 and then divide by negative 2. So the cosine of x is equal to a positive 1/2. So x is equal to the inverse cosine of 1/2. Where is the sine 0? I think this was in the previous problem, the same thing. So the sine is 0 at 0 because this is the ordered pair 1, 0. So the sine is 0. So x is equal to 0. And over here at negative 1, 0. So that means the sine at pi also. So those are the two answers for that part. And where is the cosine a positive 1/2? Well, the cosine is going to be positive here in the first quadrant and the fourth quadrant, and the reference angle is going to be pi over 3 for each of these. So that gives me my two answers of pi over 3. And coming the whole way around to here, that's going to be 1 short of 6 pi over 3, or 5 pi over 3. Okay, number 6 is this guy. It's trigonometric function, but it's in quadratic form because we got the sine squared minus a sine minus a constant. So we're going to have to factor this thing. So I need two factors when I FOIL it. 2 sine squared x, I'm going to get that by multiplying the sine of x and 2 sine of x. Now I get the factors of 3. It's only 1 and 3, so does 1 go here or does 3 go here? We need a difference of 1. So if I put a 1 there, that gives me 2 sine x, and the outers then will give me 3 sine x. Difference of 1 needs to be negative, so minus 3 and plus 1. All right, so again, we're just going to set them equal to 0. And I'm going to go ahead and just do the work on this one. So sine x equals, add to 3, divide by 2. And here then the sine of x is equal to negative 1. Well, where is the sine of x equal to negative 1? That would be right here, because that's going to be 0, negative 1. So x is equal to 3 pi over 2. And where in the heck is the sine equal to 3 halves? Should be x equals the inverse sine of negative 1 to do it properly. So here x is equal to the inverse sine of 3 halves. That's got a little problem, because if we remember the graph of the sine function, the sine of 0 is going to be 0. So I'm going to start here, and I go up, and I come back down, and that's 1 period, back to 2 pi. What was the maximum value of the sine was 1, and the minimum value is negative 1. So the range of the sine function is from negative 1 to 1. Well, then therefore the domain of the inverse sine is from 1 to negative 1. That's outside of that. So this is no solution. And that's never come up before. But you have to remember that the sine and cosine are bounded by 1 and negative 1. So the inverse sine does not exist for anything larger than 1 or smaller than negative 1. Same with the cosine. Tangent's different, because remember the tangent looks something like that, and the cotangent. So they can go off to infinity. Okay, number 8, I got a little bit of a problem because I've got the cosine squared and the sine in the same problem. I'd go ahead and move this over, but I would get a cosine squared plus sine x minus 1, and that won't FOIL. It's not quadratic. Quadratic means whatever you have squared, you have to have the same value here. Well, that's a cosine and a sine, so it's not in quadratic form. But I'm glad we know our identities, so we can look at the cosine squared plus sine squared of x is equal to 1. So I can replace the cosine squared with 1 minus the sine squared of x is equal to 1 minus the sine of x. So now let's go ahead and let's get rid of this negative. So let's move everything to the right side. If I subtract 1 from both sides, that disappears. So all I'm going to have is a positive sine squared of x minus the sine of x. Well, now we can factor out a common factor of the sine of x, which leaves the sine of x minus 1. Setting those both equal to 0, sine of x is equal to 0. Set that equal to 0, add 1 to both sides. The sine of x is equal to 1. So x is equal to the inverse sine of 0, and x is equal to the inverse sine of 1. Here we go. Where is the sine 0? The sine is 0 at 0 and pi. So x equals 0 and pi. And where is the sine at positive 1? Well, that only occurs in one location. That's here at pi over 2. Okay, these are not the easiest things in the world, but I know you can handle them. Get a good practice because pretty soon we're going to start writing the solutions not just on the interval. We're going to give them as a principal value, so only one of these is the answer. And then we're going to write the general form. We have to put the plus 2 pi n or plus pi n. And that will get explained later because I just want you to get this down.